Hello and welcome. My name is Mary Napolitano and I'm a product manager here at Standard Imaging. I'm also a physicist who's worked in industry for the past number of years. Today it's my pleasure to talk to you about Standard Imaging's IMSure QA software. The focus of today's talk is Don't Overcomplicate Treatment Plan Second Check. So let's go over a bit of housekeeping before we get started. Today's webinar will be recorded for your future review, just in case you have to step away for a clinical duty, or if you're unable to stay online for the entire presentation. Please save your questions, but feel free to enter them at any time in the GoToMeeting dialog box, and I will address them at the end of the presentation. Standard Imaging is based in Middleton, Wisconsin, and was founded in 1989. At Standard Imaging, we design and manufacture a full suite of QA products. In today's presentation, I will give a brief overview of each of the calculation modules, as well as provide details on the required input parameters as I step through the modules. Then I'll provide high-level detail of the algorithms, followed by a brief software demo, probably touching on an IMRT and a brachytherapy plan, just so you can see what the software looks like. I do have some screenshots throughout the presentation, but we'll go in and show you these things in the software as well. And then we'll finish up with some questions. So why IMSure? Well, it's easy, fast analysis of your plans. There are 4 distinct calculation modules within IMSure, and they are accessed via the icons along the top of the software in the ribbon. The calculation modules are the MU module, which is based on a single source model. It's your generic hand calculation. We would use this module for plans such as 3D conformal, SRS cones, and electrons. The QA module, it is a bit more complex. It's based on a 3-source model and is for use for QA of VMAT and IMRT plans. There are fluence map comparisons so that you can complete your gamma analysis, as well as dose point comparisons. The third module is a CyberKnife module, which of course is user specific for those people with CyberKnife. And then finally, the Brachytherapy module, which can be used for HDR and LDR. So first, the monitor unit module. This one has behind it the traditional calculation from Dr. Kahn. The MU calculation is based primarily on determining the effective depth combined with an effective field size in the plane of the isocenter, along with divergence factors from which the appropriate TMR, head scatter, and phantom scatter factors are determined and used for calculations. And so what I'm showing you here are the different parameters. You can see all of these, the effective depth, as well as the a graph of what these parameters mean. And of course, it's important that you understand when you're reviewing in the modules what we're looking at. So the projected SSD, which is shown here in the UI, I'll give a brief explanation of. So of course, you have your source. This is the central axis. This point is the isocenter. Your SSD is defined over here, and your PSSD is a bit different. Just a bit of review here. This is the patient surface, and so of course, the patient is not going to be exactly at your SSD throughout the plan, and some calc points will be off axis. And so you need to take into account that projected SSD. And so it's where the intersection occurs. So it's a bit different than the SSD. And then of course, for your calc point, you go ahead and travel on over as the graph shows to determine the projected depth, which is of course different than the depth at the central axis. And so all the corrections and the values are displayed in IMSure, so you can cross-check and understand all of the data. And so it's mostly just based on your traditional calculation. So here we have the equation that looks familiar to all of you, I'm sure. The MU is calculated based upon the prescribed dose to the calculation point. The tissue maximum ratio, the off-axis ratios, the wedge factors, the tissue correction factors, etc. And finally, the dose is calculated at each point using the equation at the bottom of the page. And specifics for the IMSure calculation are further detailed in the references by Zing et al. That I will show at the end of the presentation. So the electron MU calculation is based on the dose prescribed to the calculation point. Again, very similar. The particular cone and energy output factors, again, the off-axis ratio, percent depth dose, and corrected dose rates. The QA module is next and is geared toward plans with increased scatter contributions. One can review the 2D fluence maps along with dose points in this module. A three-source model developed by Yang et al. From Stanford is used. This model consists of a primary point source positioned at the geometric position of the LINAC target, so around in this area in the diagram, and two scatter photon sources. One is a planar disk positioned at the bottom of the flattening filter in approximately this region, and then an additional scatter source positioned at the bottom of the primary collimator. Based at the is a planar annulus positioned at the bottom of the primary collimator, not a disk source, an annulus. The transmission contributions from the leaves and the jaws are incorporated into the fluence map as well. And here are our references for this module in case you would like further information. But very briefly, I'll go into just a little more detail. But if you want much more, I would just recommend you bring up those references. So it's a three-source model. One has the total energy fluence. The first component is from the primary. The second component in the equation is the scatter from the primary collimator. The third component is the scatter from the flattening filter. And so you can see as well from this detector eye view as well, looking up toward the source, the contributions and the scatter planes. This is the scatter plane for the primary collimator scatter and the flattening filter scatter. And so you can see where the MLCs and the jaws, of course, cut off the view, the detector's eye view. For irregularly shaped fields, such as those shaped by the MLC, the fluence is calculated using the sums of the projected areas of these subfields formed by each leaf pair. And our manual provides many additional details concerning the IMSure calculation. In addition, an article by Zing et al. Monitor unit calculation for an intensity modulated photon field by a simple scatter summation algorithm, as well as computer verification of fluence map for intensity modulated radiation therapy, published in Medical Physics in 2000, are the sources of our algorithm. And I have those listed as well at the end of the presentation if you want to take a look, and would be glad to send any of that to you. So the QA module, after your plan import, automatic calculation of the MU and calculation points occur. In addition, should one choose to import fluence maps, it's not required. The calculation of the 2D fluence map then occurs. And one, of course, then needs to have analysis methods to compare the treatment planning system fluence and the IMSure calculated fluence. One can compare using the percent difference or the gamma map. And I'll go into some further detail about the QA module during the software demo. But these are the items in the UI, the histograms, as well as the maps for the fluence, and of course your MU and percent difference for each of your beams for an IMRT example. So the typical commissioning data is required to create your LINAC photon model for IMSure. So it is an independent model. Shown here is the data needed for open and wedged beams, and similar data is required for an electron model. So your TMR data profiles for the largest field size at multiple depths, output factors, of course, for the field sizes that you expect your model to be valid for, head scatter factors as well for those field sizes. And then again, similar data from the wedged beam measurements, and of course your absolute calibration. And there's, of course, a physics module where you set up your model, support of elective variant Siemens CyberKnife, and the standard beam types, standard as well as SRS. So if you want to have a second model that focuses in on your smaller fields, you can have a standard model and a small field model designated within the software. We support flattening filter free and cones as well. And then here you can see, you can review, of course, the TMR tables, both in a graph as well as in the tabular formats. And so both is there so that you are able to review the data that you have input and spot any inconsistencies before approving and validating your model. So for the QA or MU modules, we support external beam plans for wedges, photon plans, electron plans, SRS plans with cones, dot decimal compensators, mixed photon and electron plans, as well as IMRT and VMAT delivery. So with IMSure, you have a simple second check that you can use for most of your planning needs, including external beam and brachytherapy. The brachytherapy module is based on the TG43 formalism, supporting both HDR and LDR plans. The equation, of course, the dose rate equal to the air Kermas strength, the dose rate constant, your geometry factor, radial dose function, and anisotropy function. Just for a little review, diagram that I believe probably comes from the TG43 document itself, is reminds you of the specifications and the geometry associated with this equation. And so perhaps you recall that the protocol specifies the air Kermas strength on a perpendicular bisector of the source at 1 centimeter, and such that this dose rate constant is defined as the dose rate to water at a point along this perpendicular bisector 1 centimeter from the source for a source strength of 1 U. And of course, this off-axis point is then corrected based on the additional factors in the equation to correct for the non-uniformity of the source. So this is a diagram of what you'll see in the software. There are, of course, just calculation point comparisons for the contribution from every dwell or source position in the software, as well as a graphical display of the sources in IMSure. As well, one can see overall the imported point dose calculation for a particular point designated in the diagram with this yellow X. And the IMSure dose calculation, as well as the treatment planning system calculation, as well as the percent difference. And one can, of course, import multiple points to calculate dose, but in this particular plan, we have one calculation point. And I can show a bit more about this in the software demo, but one can see every source position, as well as the dose contribution from that particular point. And of course, what is QA without reports? We allow for creation of a PDF report in English, French, or Portuguese with customized details, which one can export to Excel, or of course one can save it as a PDF. And I promised a few references, and I can certainly send these to you if you request so afterwards. And so now I'll go ahead and bring up IMSure just so you can get a quick look at the software. So what I have here is I had preloaded a particular plan. This one is a 9-field IMRT plan. If I was going to reload this plan, one would simply, launch the software, import plan, and then you are connected to a particular folder that you've done a DICOM export to. And then, all of your plans are here. You can see the plan name, number of beams, and further information about the plan. This particular plan does not have a CT associated with it. My other sample plans too, but it does have fluence maps. And so you simply select the plan that you would like to import and proceed through the process. Since I've already done that, I'll just cancel, but wanted to show you the method for import. Once it comes in, there's automatic calculation of all of your dose points. Of course, you can see the TPS versus the IMSure dose and the percent differences. As well, we can review the gamma comparisons or percent differences, whichever you prefer. One can go ahead and review the histograms for each of the beams. You can see up at the top, we have the difference map and the associated histogram, and in the lower left, the gamma map and the associated histogram. And so you can see for these particular fields, the goodness of agreement. And of course, one can at any time modify your distance to agreement and percent difference as desired and recompute, but it's saved and so that it will be consistent for your analysis. But certainly one can change that at any time and recompute. So that's really an overview of what one can see with the QA module. I'll import a brachytherapy plan quickly. And so this is a HDR source plan. We have, you can see how quickly it loads and then computes automatically. We have the source results here. This is the same screenshot I showed in the presentation. This is your calc point here. You can review just the calc points. This one only has one. Look at your percent difference. You can review the sources just to take a look at which one is associated with what position. You see the one I have selected is shown in yellow, and you can look at that as well with your calculation results, the contribution, and of course all of your TG43 parameters displayed here within the software. I could load a couple of additional plans, but I think that you get a good overview of the software. And so if you would, like more details, we certainly can feel free to reach out and set up a individual demo of IMSure. You would be welcome to do that. And so just to finish the presentation, I would say just don't overcomplicate your treatment plan second checks. IMSure is a really quick, uncomplicated solution supporting most of the major LINAC vendors as well as HDR and LDR brachytherapy. It's a proven, quick, and easy to use second check. And so now I would open up everything to your questions. Go ahead and type them into the GoToMeeting dialog box. So far, I don't see any questions, just one hello. So I'll give you a few minutes to type some questions. And then if there aren't any questions, I'll go ahead and close the session. So here comes a question. Can we do a calculation for a stereotactic treatment? Yes, you can. And you would probably want to, customize a separate model to do that, and that is a capability of IMSure. Okay, well, it looks like that's everything we have for today. If I didn't show any of the plan types that you were curious about, feel free to reach out, and have a great day. Thanks for joining.